When it comes to personal hygiene, there's not a lot of overlap between dinosaurs and humans. But a new study suggests early feathered dinos suffered from a familiar affliction, dandruff. As Ian Sample at The Guardian reports, researchers have discovered the skin flakes from several feathered dinosaurs that flapped around about 125 million years ago. Paleontologists weren't initially looking for the fluffs of skin, reports Matt McGrath at the BBC. They made the discovery in 2012 while studying the fossilized feathers of Cretaceous-era dinos using electron microscopy and chemical analyses. The feathered dinos included the crow-sized Microraptor, an early bird species called Confuciusornis, and two larger feathered dinos called Biopeosaurus and Sinornithosaurus. When we were looking at the feathers we kept finding these little white blobs, the stuff was everywhere, it was in between all the feathers, lead author Maria McNamara from University College Cork tells McGrath. We started wondering if it was a biological feature like fragments of shells, or reptile skin, but it's not consistent with any of those things. After eliminating the many possibilities, the researchers concluded the fragments must be pieces of preserved skin. It's identical in structure to the outer part of the skin in modern birds, what we would call dandruff, McNamara tells McGrath. They detail the find in a study published in the journal Nature Communications. Find suggests that instead of sloughing off their entire skin like reptiles or snakes, the skin of these bird-like dinos flaked off between their feathers, just like modern birds, according to a press release. But there are some differences. Dandruff in birds, dinos and humans is composed of cells called corneocytes. In modern birds, these corneocytes are fatty and keratin is loosely packed, allowing the birds to not only shed dandruff, but help them stay cool while doing energy-intensive activities like flying. But the latest fossils suggest that dino corneocytes were more densely packed with keratin. Here's no evidence they had any fats in these cells at all, McNamara tells McGrath. This means they probably didn't spend much time in the air thanks to less efficient heat exchange. Their body temperatures were also probably lower than modern birds, almost like a transitional metabolism between a cold-blooded reptile and a warm-blooded bird, says McNamara. If these feathered dinosaurs couldn't fly, then why did they have feathers? Researchers aren't sure exactly why the first feathers evolved, but there are many possibilities. Fuzzy feathers could have been used to insulate eggs in nests and larger feathers could shade eggs or young. Lighter-weight feathers may have replaced the bony crests and elaborate horns some used to attract mates. Since critters can molt, they could then change color for camouflage during certain parts of the year. They could have also helped some dinos with balance. Whatever the case, dandruff was a small price to pay for one of nature's coolest, most elaborate developments yet. Like this article? Sign up for our newsletter.